Welcome to the 2018 Tezos Winter Meetup. It's been a few months since our last meetup. So I see a lot of familiar faces. Last time we had the Brightmans and Tezigator. We had Steven remote. Slightly different lineup this time. So, there's been a lot of events, a lot of drama going on. And we can discuss this at length in the bar. But for this meetup, right now, it's more about all the work that's been going on behind the scenes. People just spending days and nights just working on the technology, getting stuff ready for the launch. So let's stick to that, and then at the bar we can go crazy. So there's three things we're talking about today. So this is the home of cryptonomic. So we're going to give you a dev update. So a few months ago, we kind of started out our projects, and now we're going to talk about where we are now. So Tyler and Marina and myself are going to present 3 of our projects. And then Milo Davis from DLS, he's on Hangouts, and he's going to do a remote talk this time. He's going to talk about the formal verification of smart contracts, which we're quite excited about. And then all the way from New Zealand, we have Stephen Andrews in the back. He's going to be speaking. A lot of you know him really well, I assume. Now you can meet him in person. So he's got a suite of really cool stuff, and he's done some really interesting work that he's going to show us today. So also, this is also a Brooklyn Desk event, so we have some people here who might not be very familiar with crypto. So we'll just do a lightning intro. So Bitcoin, everyone's heard of. It's a digital currency. It's decentralized in the sense that no one controls it. It works across borders. It works across time zones. And it's also a shared ledger. Anything you put on the Bitcoin ledger, you can't change. And it kind of stays there for public viewing for eternity. Ethereum also is something that a lot of people have heard about. It's like Bitcoin, but it's like a global computer. You can run code on it. The execution is fully transparent to everyone. The results are transparent. No one can modify it. So all this has allowed us to build censorship-resistant and decentralized applications. So decentralized organizations, decentralized systems, but I'm sure most of you are quite acquainted. And Tezos, that brings us to Tezos. So Tezos is what we're here to talk about today. We're very excited. It's similar to Bitcoin and Ethereum, but it's got some unique features. So it's got a formal governance process. So what that means is Tezos is launched with an initial constitution, and then people participating in Tezos are able to dictate amendments to the constitution such that they kind of govern the direction in which the project takes, the technical direction and also like broadly in general. So in some sense, it's one of the most radical experiments in large-scale decentralized governance ever. So it's going to be really interesting to see, once it goes live, how it pans out. And the other thing is formal verification. So Milo's going to talk about it in a little bit. But with all these mission-critical applications that are slated to run, and applications that handle people's data, people's finances, you want stronger guarantees that your code works properly. So the way Tezos is built, it's easier to have some formal guarantees, mathematical guarantees, that many aspects of the code are indeed behaving or set to behave in the manner that's specified. So that's why we're excited about Tezos. So that was the intro, but it looks like most of you guys are very familiar. So I'll just move to the cryptonomic part of the conversation. So we are obviously based in Bushwick. And what we're doing is we're generally committed to building decentralized applications and a decentralized web. But right now, our focus is on building an ecosystem of Tezos tools. So the intention is, whether you're a mobile developer, a web developer, whether you're doing a sandbox for a corporation, it should be as simple as possible for you to interact with Tezos. So we have a set of tools, some of whom you're going to see today, that hopefully allow that. And all our tools, and especially the ones you see today, can also be used in a standalone manner. And work is ongoing. Obviously, it's a new frontier, so By the time the Tezos network launches, our tools should also be integrated, hopefully. So we're going to talk about 3 things today. We're going to talk about RNX, which is a block explorer, Conseil, which is an API for Tezos or blockchains. And we're going to talk about Nautilus, which is blockchain infrastructure. Nautilus is what everything runs on. So we have first Marina, and she's going to talk about RNX.
Hi, I'm Marina. I'm the UX UI designer here at Cryptonomic. So in building a Tezos blockchain explorer, we wanted to do something that is not available right now on the market. So currently, solutions only allow you to do simple lookups. What we wanted to do is create a solution that allowed you to do more refined searches and do these searches across multiple networks. So we came up with a well, currently we have a prototype. It's still in development. So I will take you through the prototype now. Have a little patience because it is a little, I mean, it's pretty fun. It's a good time. So meet Aeronax. And you can see here that we're going to display the latest block information and then have information about how the tool works and what it does, which is another thing that a lot of block explorers don't have. They don't actually explain what they do. So say I want to do a simple lookup. I enter a block ID or a block hash up in the top search bar, hit enter, and then the tool loads on another page. Here I can have my more advanced filters on the side, and I get the single view here with more advanced information below it. I can minimize and expand the view as I see fit. And then by hitting the Operations tab, I can see all of the operations that exist within that particular block. But we're here to do more advanced functionality. So I go back to the Blocks tab and say that I want to view all blocks that exist greater than the level 60,000. So I hit Add Parameters, and then go through this, add greater than 60,000, enter, and then I get all blocks that are greater than the level 60,000. And then in more advanced developments, this would be able to sort by greater than or less than. But then here's the real kicker. What if I wanted to see specific operation sources that occurred within these blocks? I can add operation sources here in the side filter, hit enter, and then it will spit out all the blocks in which those operation sources occur. So that's what we got going on right now. Where'd that go? What happened to the presentation? Okay. There we go. Sorry about that. So obviously we are still in beta and looking for testers. Doesn't matter what your experience with blockchain is. If you are interested, please come talk to me either after the presentation or at the bar. Thank you. Any questions?
None.
Cool.
Thanks, Marina. So I'm back. RNX is being built out right now. It's in TypeScript, React, blah, blah, blah. But it uses Conseil as a source of its data and eventually for everything else. The Conseil is a tool for developers. So Conseil lets web and mobile developers write applications against Tezos. So for the technical people amongst you, it's an actual API. And the whole idea is to reduce development complexity, right? So if you want to do something with Tezos, and you're not necessarily interested in the nitty-gritty details, then you can just work against our API. Steven's tool, EasyTZ, is very similar. I think they work well together. And the whole intention is to remove all the complexity, abstract it out, and you just do what you do best. So there's a lot of ongoing work with Conseil right now. Making it resilient to forks has been non-trivial. So and there's some similar issues. Once that's done, we'll be in alpha. Right now, it's pre-alpha. So anyway, let me show you a little bit. So if you go to our GitHub, Sorry. Yeah, if you go to our GitHub, you can see our API spec. So certain developers amongst you will recognize an API spec. So there's a bunch of, oh, this is actually kind of outdated. Yeah, well, anyway, there are a bunch of routes that give you information about blocks, accounts, and operations. And although you can't see it at the moment, there are also write routes. So you can actually originate accounts and send transactions and so on. So maybe it's better to illustrate that by actually interacting with Tezos, with Conseil. So this is Postman. Postman is a tool for interacting with APIs, if you're familiar. Some of you are nodding. So interacting with APIs. So let's get the current blockhead. So looks like we're currently at level 64,441. Let's do something else that's maybe a bit more fun. So last time we had Tezagator. He was, he's one of the major delegates on the Tezos scene. And it's been very busy, I assume. So we can actually look at all the accounts that are actually delegating to Tezagator at the moment. We'll restrict it to 100 because we don't want to be too crazy. So forgive the, whoa, that's not good. Probably should have used my own laptop. Technical difficulties. Let's see if we can get any accounts at all. Well, that's not good either. Okay. I apologize. Maybe we'll look at some operations and hopefully that works. Yeah, so once again, we can pull a whole bunch of operations. Let's say we specify a source, then it drills down to this specific source. Right, it would have been really nice to actually look at Tezagator's activity, but it's a demo. Things have to go horribly wrong. But the key is we have up to 10 kinds of, low resolution. The key is we have up to 10 kinds of parameters, and you can mix and match them. So that allows you to drill down into operations that you're really interested in. So there's a bunch of write operations. You can get all the information that you would on a block explorer. And you can also do things like key generation. So there we just generated a key. There's a bunch of write operations. I don't want to bore you, but if you want, you can come by after the talk and we can explore a little bit. So as you can see, it's in pre-alpha. Our accounts feature did not work. But the code is up on GitHub. You can have a look if you want pre-alpha access. Talk to us or send us an email at api@cryptonomic.tech. And that's going to say. Any questions?
Hey guys. So Nautilus is infrastructure for blockchains. Right now we're working on Tezos. Yeah, what's wrong with it?
Keep talking? Okay, you're good.
Yeah? Thanks guys.
Just in case, sorry.
Yeah. So we started this when we were working on the Tezos AlphaNet. How many of you have worked with the AlphaNet? Has anyone set up a node or anything? No? Stephen Andrews has. So it's an AlphaNet. It's constantly updated, and sometimes it's updated and there's bugs. It goes down. It's an unreliable node to work with. So we wanted to build a reliable one. and also build something that could be very reliable for lots of people to use for various purposes. So we built in load balancing, automation, and monitoring so that we could know, what's going on with the node. Set up, the automation was to set up, spin up several nodes with just a click of a button, and also the automation recovered in case a node went down for whatever reason, and they go down for all kinds of reasons. It would just automatically spin it back up. So we put this out there to the community. A lot of developers were working with the nodes and having issues, and if they didn't want to work directly with the node and just wanted to build on top of it, they could use our infrastructure, and they'd always have a running node. So then we started building on top of it. That's how Conseil, that's what Conseil sits on. It sits on that infrastructure. And if you're interested in working with our infrastructure, that first link is how you use it. And then if you want more information, the second link is where you to go to. So in the future, we hope to expand this. When mainnet launches, the nodes will obviously be more reliable. But we want to provide this as a service so that if you want to deploy a number of nodes on, you can just click a button. I want 5 nodes in these regions. I want to do it on AWS, whatever. We hope to make that easy for you. So that's what's coming in the future. That's basically it. Any questions on this?
You can talk.
Milo, do you hear us?
Hear you. Can you hear me?
Ah, perfect, perfect. So Milo Davis, everyone.
Milo. You might know me from my blog, which is mikkelsenlang.com, or Tezos. So I was an intern with Tezos in Paris up until about a month ago, and now I'm working for them part-time while I actually finish school. So if you have a question, I guess raise your hand, shout it out. Okay, cool. Hopefully you guys can see that. Good. Slides, yes? Look good. Okay, cool. So formal verification and Mikkelsen. So Mikkelsen, for those of you who are not aware, is Tezos's smart contracts language. Fiddly language to write, but it has some very nice properties we're very happy about. This is sort of directed it as an introduction, both to formal verification and can be applied to Mikkelsen, sort of the start of some mathematics. Firstly, what is formal verification? You're basically building a mathematical proof about your program. And so it's a lot more powerful than because you've proven it for all cases. So you don't have to worry about test coverage. You have basically proof coverage that covers 100% of your code. The downside is it is way more difficult to do than tests. It's very, very hard. It's very, very complicated because you don't just have to enumerate some cases. You have to actually prove a property about code that might be written in a convoluted way for efficiency or for other reasons. So taking a look at an example, this is a function to compute the maximum of 2 numbers. I've got it on the left in Python and on the right in OCaml. 2 numbers, x and y. If x is greater than y, it returns x. Otherwise, it returns y. So this function should be relatively straightforward. But indeed, it already presents the first problem you'll encounter if you try to formally verify anything, which is specification. So in order to prove that something has a certain property, you need to state the property. And the property, even for a really simple function, like the maximum of 2 numbers, is not necessarily so simple. So x and y, the max of x and y needs to be greater than or equal to x, and the maximum x for y has to be greater than or equal to y. All right, so that seems like that's a pretty clear definition of what you're supposed to do. That the maximum is equal to x or the maximum is equal to y, because otherwise I could just return the maximum integer and have a completely broken function that would still meet the first line of the spec. And this has a lot of important implications that make formal verification way more complicated. The function has to terminate, which means in a finite amount of time, this function needs to finish executing and give you back a result. Once you start having non-terminating functions and code in your system, everything gets fast. So you basically need a termination proof with every single thing you formally verify. And in Tezos, that's even more complicated because we have gas limits to consider. So getting into sort of one way you can do formal verification is what's called Hoare logic. This is from Tony Hoare, who is the inventor of quicksort, among other things. And this is a great way to reason about programs. Right here, 5 rules, and they allow you to verify simple imperative programs. And this is not what I think we should use for Tezos, but understanding of insight into how formal verification works in general and how this can become useful. So the way Hoare logic works is you have a precondition and a postcondition. So before you execute a statement, there is some state statement about it P are true, and after you execute the statement, some statements about it Q or R or S or some other letter is true. So for example, Hoare logic tells us that if you have 2 statements, some statement P, and it's true, then S1 executes, and then some statement Q is true. You have some state you know about the universe. Next statement, Q is still true. Now R is true. You know the composition of those, so S executing S1 and then S2 will give you back a state in which R is true. So this gets more complicated. A mouse somehow? No. Okay. So it's a little hard to point at things. But looking at the second rule, you have a conditional, and you know the condition was true, so that gives you more reasoning power. So if we're going back and trying to prove things about the maximum function, we know that in the first case, or in the then branch of the if statement, the number x is actually greater than y, and that's a very powerful tool for reasoning it about what's going on in that branch. In that case, you know that that wasn't true. There's a loop invariant rule, so essentially for while loops, statement P, which is true for every cycle of the loop, and then when the loop ends, P is still true, but you now know that the condition is false. So this is very powerful. Invariants are this great tool for reasoning about all kinds of programs, because you get this idea that some property is true with 0 executions of the loop, so if the condition is initially false, or for 1 or more. So for however many times you go in the loop, this condition is never falsified. Assignment, it's a substitution. And then the consequence rule allows you to strengthen your theorems. So if you have some P, you can strengthen that to P prime, and then get some kind of Q prime, and then weaken Q prime back to Q. So that's just a little bit of a technique you can use for proofs. So I'm going to actually pop back and see you guys again. Did that make sense to everybody? Like, did I lose everyone when I did that? I can't hear you, so maybe someone can give me a sign. That'd be super helpful.
All good, Milo.
Okay, perfect. All right, back to the slides. Cool. So looking at Hoare logic, there's a big emphasis on the invariants, the things that never change about the program. So even when you're reasoning about state, you're looking at the properties that are true about your code, about how these properties are preserved, because those are the properties that you're trying to specify. You're trying to specify the contract does the right thing and ends in a good state. You're not just trying to specify, it did these things, and we don't know why, and we don't know what state it ends in. And so the idea of what the invariants are and how they're preserved is basically the essence of how formal verification works. It's about that your things that are always true remain true and your properties make sense. Just over to Michelson. We really only care about the observable state of a contract, so what it does. So this can be expressed in a trace semantics, which is basically you walk through the program and you see what it outputs. So you can look at a state and you can prove program equivalence using that method. Care about the transfers and the stored state, whether a contract fails. So when it transfers to another contract, you care about what data goes in that transfer. So if you transfer to contract you give some contract to A and it transfers to B, you care that it gave the right data to B to transfer to. State. So whenever you store state, that's going to be very important because that can influence how your contract executes. And then you care about whether a contract fails and very clearly about when it fails, because if you get invalid inputs, you might want to check them and fail in the case you get bad data. Very, very important for verifying contracts. Brief disclaimer, I'm going to present a little bit of math, not too much math. I'm building a tool based on these ideas. This is not the only way to go about formally verifying smart contracts. My tool is based on SMT solvers. I think that's going to work and be easier to deal with, but you might want to use something more powerful like the Koch theorem prover, and there's formalizations in F-star too, so they might be better choices depending on what you're doing. So first thing you need is a storage invariant. So an invariant is something that is always true. Declare some property that is true always about ever you start the contract, you know it's true, and every time you go through, that guarantees that you're going to have this property. And this property could be something like the integer is you have an integer and it's the number, it only increases. That would be it's greater than the last execution. You could say that it's always odd if you for some reason need that property. The list of if you're for example having a token contract where a contract where everyone is putting in money in Tez, all that money to add up to the balance of the contract, and that would be something you want to preserve in every execution of the contract. So you basically have some property P storage, which is some property of the storage, and that's got to be preserved. Contracts aren't going to necessarily execute all the way through. You have some statement about an input and the storage. You have certain conditions met. If Q is met, you do not reach a fail state. So that's a progress theorem, which means if you give me a well-formed input, and the rules for specifying how you determine something is well-formed could be very complicated or very simple. Give me a well-formed input, I don't fail. So I go through and the contract executes. And then also, if you give me a malformed input, if you don't give me something that is good, I will definitely fail. And so that's how you basically say that I'm preserving my condition, and the contract will not execute on a bad input. Very important. So that together can get us basically the start of partial correctness, which is the correctness of the contract, an input, and a storage. Basically to prove that this property holds and that your storage property holds as well. And you're given P storage, so you're given that your storage invariant is true, that your input is well-formed, and your input is well-formed. So given those two things, if you can prove that correctness property, which could be arbitrarily simple or complicated, variant is maintained, you have partial correctness. So you know that your contract will do something reasonable for your inputs, prove those other two theorems as well about the checking, so the ones from the last slide. That's not full correctness. So non-terminating code is being fully correct in normal formal verification. So you basically get what's called a definitional principle. So when you admit code into your system, in this case, when you say a contract is correct, you can prove. But in Tezos, you need to go one step stronger than that, because you can't just say infinite amount of time, because I could give you a contract in way longer than the heat death of the universe, and Michelson has gas and it'll choke off your execution. So you actually, for full correctness, need to reason about gas consumption. And that gets very, very complicated. Reasoning about resource uses requires you to prove not just asymptotic complexity, but the actual complexity. It's incredibly difficult to actually do this. So for now, I'm just punting on it for my tool, and it's not going to touch that. Basically, hopefully a brief and digestible explanation of if you have any questions about this or Tezos or anything else I'm working on, feel free to pop back.
For all the way from New Zealand, Stephen Andrews.
Cool. So I was presenting via live stream last time, and my big focus is decentralized applications. Just a show of hands, anyone here into web design or app development or anything like that? Anyone working with decentralized apps or have worked in the past? Cool. And anyone looking to build something on Tezos, a decentralized application on Tezos or anything? Cool. Well, hopefully after this, you'll get a better idea of what tools we have available to help with that. So let's get into things. So essentially, a decentralized app or a DApp or a DApp is, think of something like Airbnb or Uber, but without a central group controlling that data and the flow of the data and how things get calculated. So it's a transparent way to operate some of these applications, and things like Ethereum and Tezos makes this a major possibility. So a decentralized application that pretty much merges standard application technologies like web-based apps, mobile apps with the blockchain. And what it does is it helps to improve the usability or the utility of the protocol. So as you build things on top of Tezos, you improve Tezos' worth and value. You improve the adoption of Tezos, and that in itself helps to feed the protocol itself, and more people will be attracted and will improve that protocol, which is perfect for Tezos with the governance and the ability to submit protocol upgrades. So it's something that as more people come into this, you'll see this thing just get bigger and bigger and start adding additional things. So just a few of my projects that I'm currently working on. I've got the EasyTeasy.js library. It's for those who know Solidity, it's a Web3-like library, and essentially it means that you can interface your HTML web app with the blockchain with this JavaScript library. Next up, I've got Phi. You can say Phi, Tezos, however you want to say it. It's a high-level smart contract language for Michelson. And you can think of Solidity as to the Ethereum virtual machine code. So that's that. And then Tezbox, which is a browser plugin like MetaMask, as well as a mobile app. And the main thing I'm about is frictionless app development. So for me, there are three things that you need for decentralized app developments on top of actually being able to build an app. And that's a way to communicate with the blockchain, and that's what EasyTeasy does. A way to write the smart contracts in an easy way, which is what Phi does, and then a way for your end users to interface with your dApp, which is what Tezbox does. If I'm going too fast, just tell me. It's how we speak in New Zealand. That's why we don't understand each other half the time. So EasyTeasy.js, it's available on GitHub, just /Stephen Andrews, EasyTeasy. It's currently in beta, and that's mostly because the protocol keeps changing. So I think in the latest Tezos update that Arthur uploaded this evening, he said that they're going to reset the whole AlphaNet again with the updated code. So if tomorrow they do that, EasyTeasy probably won't work. It's going to break half of it. So it is still in beta. It does incorporate about 90% of the functionality of the native Tezos client. So that's creating accounts, delegating, sending transactions, and things like that. And the aim for me when I was building it was to rebuild the OCaml source in JavaScript. And then finally, it does utilize the question?
Sorry, your goal was to rebuild the OCaml source code in Java?
In JavaScript. So basically take the functions that the OCaml source code does and rebuild it in a JavaScript library. The Tezos, the DLS are planning on doing that. They've already kind of started mapping this out. When I first started doing this, it was easier for me to just build it and start exploring how the RPCs work. And then obviously I can start building different APIs for things like PHP or C# or other languages as well. So it's more of a learning experiment, and then by sharing what I produce with everyone else, it just means there's an easy library for people to start using. So yeah, so that was kind of the reason behind it.
It's right now still in JavaScript, right?
What was that, sorry?
It's still written in JavaScript, right?
Easy teasy?
Yeah.
Yeah, it's completely JavaScript, yeah. And then by default, it communicates via the Nautilus service, which the cryptonomic guys are running here. So yeah, it's pretty much a code base that uses the Nautilus provider. You can change that if you want, if you've got your own node set up. Examples of where it's used. I've made a decentralized app already called Lucky Tiers, which is like a lottery app on top of Tezos. There was an ICO that ran in August or September last year, the betting win app. I'm not sure how much they raised in funds, but they've completed the smart contract type side of things and are using EasyTeasy for their web-based app. I know of someone who's working on a decentralized exchange as well as on ERC20 type tokens. I'm looking at building a lending platform similar to ETHLend and SALT on Tezos using EasyTeasy to communicate with the blockchain. There are a couple of other projects from community members that I'm not allowed to share, but there's big interest out there with regards to decentralized apps. And then Tearsbox uses it as well as a command line tool built, which runs in Node.js. And it's pretty much a copy of the Tezos client. So then moving on to Phi. So like I said, it's like Solidity, and it's JavaScript-like in its syntax, so it's a lot easier to learn and read for new developers or developers coming from Ethereum. It compiles down to valid Michelson code, and based on what Milo says, you can then verify that formally once those tools have been developed. It is in alpha at the moment. I'm still working on it. Changes to the protocol, the language in Michelson have affected how easy it is to use. So it's still in the works, but I've got documentation up on pretty much everything you can do within it. And yeah, we're looking at getting the compiler and the beta online soon. So yeah, keep an eye out on that. Examples of it being used, like I said, I used it to build the Lucky Tiers smart contract. There's an identity smart contract being built with it, which is similar to Uport. The blockchain lending platform that I'm looking at is also going to be built with it, and then there is an ERC20 type-like token that's been created with Phi and copied to things like liquidity as well. So yeah, there's tons of interest, and people are definitely using it. So just to show the difference, this is the source code for Lucky Tiers. If you're not a developer, you probably have no idea what that means, but it's pretty well set out. You can actually read half of it. And essentially what this does is it defines the objects we use, defines the constants, the storage variables, and then has a function for betting. And that actually compiles down to this. This is the Michelson version of it. So at the moment, if you don't use something like Phi, you're expected to write that, which is a lot harder. Liquidity is the other option for a high-level language, so I've got a quick comparison. The pros, it's easy to learn and read. Liquidity is quite similar to OCaml if you've had a look at it. I've managed to develop contracts and compile them with it, but I still believe Phi is a lot easier to play with. It's better for existing smart contract developers, so Solidity developers or anyone coming from another blockchain. And it's a lot less work to set up. The idea is that you'll be able to compile it within a second, and anyone can potentially compile it on any operating system. With Liquidity, there's quite a big setup involved. It's similar to setting up a full test system. Yeah, that's something that we're trying to provide. It's all on. I haven't looked into it too much. it was something that I had brought up at the last meetup, was to ensure the consistency between the contracts and that what's being produced is actually what you're writing, because that in itself is a huge security issue. If what you're writing is sound, but then what gets compiled has a huge security flaw in it. So that's something that's definitely been looked at. It's just not something I've gotten around to just yet. Yeah.
Which language or platform are you implementing this in? The compiler?
This is for fee.
No, but which language did you implement it in?
It's written in JavaScript. Yeah.
So, like, well, my question is more like, do you have any plan for proving it, formally verifying the compiler, or?
Yeah, definitely. So I've been waiting to see who out there is good enough to start doing security audits on Tezos related code. I hear that the DLS have already found someone to start auditing their stuff. So once they announce who that is, we can start looking at maybe getting them to do audit some of my stuff and see how much that costs. But yeah, essentially because it's a new space, we need someone who can do it and knows how Tezos works. But yeah. The cons is that it's only me behind fee at the moment. I don't know if you know, but liquidity is backed by the full OCaml Pro team. So yeah, there's a team of people behind that language. Theirs is more similar to OCaml, so the compilation is a lot different. It's a lot more streamlined and quicker than what I'm doing with fee. So the end result code lengthwise would probably be a bit more streamlined and efficient using liquidity at the moment. And then finally, they're closer to the source, and by that I mean they also work on the protocols. So these guys can kind of get a heads up on where things are going with the Tezos protocol and ensure that liquidity is moving in a similar direction. So they've got an advantage there as well. Moving on to Tezbox. It's currently live and it's in beta. It will be 100% operational for launch, which is said to be in the next 5 or so weeks. It's a browser-based app like MetaMask, as well as being an Android app. Currently, it's only available on Chrome and Android, but I've got a Firefox version that just needs a couple of bug fixes, as well as an iOS version to release too. And this uses Nautilus again for blockchain communication. You can change that if you have a preferred way to connect to the blockchain. The EasyTeasyJS library, as well as the Aronx Explorer once that goes live. And it also uses actually it will use the Conseil API to pull in transactions for each account. And you guys didn't really see it, but that API has a lot behind it. And it's just unfortunate it didn't work for Chuck when he was up here. I saw it fully working before. But the example he was trying to show was who's delegating to a specific person like Tezgator. And currently that can't be done with the native RPC APIs. So all of these delegation services have to build that themselves. They have to be able to figure out who's actually delegating to them so they can calculate the rewards correctly. There's no native way to do that. So something like that was huge for delegation services and people who want to get into that space. They've now got a set API that they can rely on to help calculate that for them. And that's what I'm doing. I'm pulling through transactions from that Conseil API, and we're going to be listing them in Tezbox as well. How can it be used from a development point of view? Essentially, I've built an API within it as well, which allows dApp developers to tap into a user's wallet, retrieve their balance, and then request them to accept a transaction or to sign a message. So essentially what MetaMask does at the moment, and it completes that full triangle, having a way for users to interface, a way for your dApp to interface with the blockchain, and then having an easy way to make those smart contracts. Some other projects I'm working on are TZ Oracle, which is a Oracleized IT-like project. I had a working version of it. I haven't originated it on the latest Tezos blockchain, but essentially it allows you to hook into external web services. Imagine from a smart contract being able to pull data via a web-based HTTP request and then have that data brought back into your smart contract. Tez RPC was a community-run node network, similar to Nautilus with nodes set up by the community. but because of how hard it was for users to be able to maintain and set up those nodes, it pretty much just piggybacks off the Nautilus service at the moment. A light baker is something some people here might be interested in, is the ability to bake without having to run a Tezos node. I actually was able to run a baker from my Android phone, and it worked for days on the AlphaNet. And it means that you can hide your device or whatever you want behind a Tor proxy, and your computer is completely off the network. No one can gain access through it. When you're running a node to bake with, you're exposing your IP to everyone. So it just makes it a bit more secure. And then you can do things like hooking into a USB-based wallet to complete those signatures as well. And then finally, I'm working on a desktop wallet, which will be ready for launch as well. To contact me, just check out my GitHub /Stephen Andrews. I'm on Write at Stephen Andrews or Twitter at Tezbox_wallet. So yeah, any questions?
You're working on all these projects?
There's about a small amount of them, but yeah. Yeah.
So are you right now, it's just you and...
But yeah, there's been a couple of pull requests. If anyone else wants to contribute, please do. If you find bugs, that can be helpful too. Just to tell me what's wrong, and I can put it at the bottom of the list. But I'll get around to it eventually. Yeah. Anything else? Good.
That's a really interesting point that you brought up with the light baker. The notion that if you're actually baking it or you want to run a service, then you are sort of wandering into the wild west of security concerns.
Yes.
Like you don't really know how good the sandbox is.
Yeah, definitely. Yeah, and that's something that both Tezgator and Mike from My Crypto Delegate are worried about. So yeah, that's why the idea of having a light baker that you can run through a Tor proxy. So pretty much the light baker does all the signing and the transactions, and then you would connect to something like Nautilus through a Tor proxy to help keep your IP and things secure.
Do you introduce new problems by going through a Tor proxy, for example?
Potentially, I haven't actually gone through a Tor proxy. I've gone through a standard proxy. They're just options. It still works out like, it's still fairly secure.
But there's two concerns, right? One is hiding your IP address.
Yes.
The Tor proxy. And second is, I don't know, breaking out of the sandbox, maybe? Like actual security alerts when you're running a baking node on your own machine.
Yeah, I haven't looked into the security of the baking personally. I think it's a better method than using running a node and a baker on the same system. Just because if someone can, if you run down AWS and someone manages to, hack into that, then your private key's going to be right there. But yeah, it's something that I think the Tezos team are looking at addressing, but yeah, nothing's been mentioned from them yet.
For now, your efforts focused on anonymity, right?
Yeah, definitely, yeah. That's cool. And exploration is more to see, can this be done? Yeah. Yeah. Anything else?
How does one use those dApps that you have?
Not all of them are mine. Where are these? Oh, they're somewhere. The only one that I've got up there that's live is the Lucky Tears one, so luckytears.github.io. It does require me to re-originate the contract, which will probably happen after the reset. I'm thinking the reset's going to happen in the next week or so, and then another week to update all of this to work on that. But yeah, the other ones I don't think are live or haven't been published, based on what I know from those developers. But yeah.
Talk to me about Tezbox. How secure is it?
So it's decentralized. All your private keys are stored on your device. It's similar to MetaMask if you're running the browser-based version. So it uses the Chrome environment, which is fairly secure. By fairly secure, in New Zealand, it means like that's as secure as it's going to get. So don't think I mean it's like only this much. But obviously, we'd want to get that code base security audited as well. And by we, I mean me, because it's just me.
And does it have an application? I mean, can you download an app on your phone or you run it on the web? Or
Yeah, so it is a web-based application and a mobile app. So I've got the app here. And then it's just pinned. It uses the native keychains to store the private key data, which according to Apple and Android are secure. But yeah, so all your private keys are stored on device. It's not like a system where we store it in a database and hold it for you and you connect it through us. So it's a decentralized wallet. Does that make sense?
That makes sense, yes.
Yeah, so you have full control of all your private keys and you don't have to release them or send them to someone else to store for you.
Okay.
Cool. Awesome. Well, yep.
So it's a bit of an open question, and also to the economic guys as well, if you want to answer, but what technical project do you think is lacking the most attention in development at the moment? Or non-technical project?
And related to Tezos? I think delegation hasn't been addressed as much as it should have been. I would say that they must have a plan, but from what I've heard from both Mike and Bo for Tezgator is that they're left in the dark for most of this. They're guessing most of it. Things have been changed about 4 or 5 times now. They've been told stuff in the past which is totally different to what's been announced now. So I think that's a huge issue. I think a bit more focus could be put into that. But obviously the whole team's focusing on just getting it launched.
You mean just being able to delegate your stake to someone else?
I think delegation is fine. It's more that delegators have no idea how to set up their services to be able to work with the Tezos product. They have no idea what the reward's going to be, how long they have to lock up, and things like that. So yeah, from what I've heard, that's a huge issue.
And another thing I'd add is, just because it's an important facet of Tezos, I don't think anyone's done a lot of work with governance, and that's quite a big challenge, completely understandable, and it's completely fine, down the line. Once everything else is stable, then it makes sense to do governance. But yeah, that would be my answer. That's okay. So governance, balloting, voting, so Tezos has governance as one of its main features. So at some point we must participate in the governance of Tezos. It's not really been done at this scale before. So it'll understandably take some time, but that's the one area where we're really interested to see how the core team progresses.
Yep.
So I have a general question. So governance and delegation, right, are they two separate? For example, I delegate my stake to someone. Then when it comes to governance, can I do my own?
No, they're bound at the moment. Yeah.
Okay.
So the delegate gains your governance power as well. I believe that's something that they're looking at revising, but yeah, at the moment it is bound.
Well, my crypto delegator stated that what they're trying to do, even though you're delegating to them, they will explain to you the process on what is being asked to be voted on, and then ask you to choose
Yeah.
amongst other people who delegate to them, and then based upon the feedback from the public, then they will vote that way.
Yeah. Yeah, so I've spoken to Mike about that. He was asking me how it worked. The thing is that he doesn't know if he can delegate, say, 40% for and 60% against. I think being a single delegate, he can say yes or no. So if he's asking you guys to vote, and it's a 51 to 49%, he's going to go with the 51, even though the 49% don't agree with it, and they could have affected the end result if they weren't delegated to him. So it's definitely a solution, but it still leaves a huge hole, in my opinion. Cool. Is there anything else?
Tezbox could be downloaded Apple iOS.
Will be soon. Yeah. Yep. I've been having issues with the app store for a while. I'll post an update on my Twitter, but give about a week and it'll be available. Cool. Right. So yeah. Anything else? Come find me at the bar later tonight. I am part of the association that launched the T2 Foundation. So any questions about that, feel free to just find me at the bar and have a chat about that. But yeah. All right. It was great speaking to you guys. You guys have a good one.